Star Wars, Guardians of the Galaxy, Futurama, Rick and Morty. What do they all have in common? Space!
Even though the sci-fi component may only seem interesting and relevant to us in entertainment, did you know the mathematics we learn in school could also be applied in the study of astronomy, the solar system, and all things space? Here, we'll look into three aspects of spatial mathematics: orbital lengths, speeds of planets, and man-made satellites.
Let's start off with orbital lengths. So, orbital lengths are measures of distance and time in relation to an astronomical object's orbit around a star or a planet. For example, the Earth's orbit around the Sun or the Moon's orbit around the Earth. Orbital lengths include the average distance between a planet and the Sun. Earth's average orbital distance from the Sun is almost 150 million kilometers, while the closest planet to the Sun, Mercury, has an average distance of only 58 million kilometers. We say average because an orbit is not exactly circular, but rather it is more elliptical. That said, orbital eccentricity is also another orbital length and is a measure of how far a planet's orbit about the Sun, or the Moon in relation to the Earth, is from being circular. The larger the eccentricity, the further the orbit is from being circular and the more elliptical it is. Another simple orbital length is the distance travelled in one complete orbit. Orbital velocity is the average velocity or speed at which a planet orbits the Sun and is expressed in kilometers per second. Similar to the distance between a planet and the Sun, the speed of a planet during orbit is not consistent. Some more interesting orbital lengths are perihelion, the closest point in a planet's orbit about the Sun, and aphelion, the furthest point in a planet's orbit about the Sun. For the Moon, the closest and furthest points to Earth are given the terms perigee and apogee respectively. Finally, an orbital period is the time it takes a planet to complete its orbit and is expressed in Earth days. As we all know, the orbital period of Earth is 365 days roughly.
Let's get back to the distance between planets and the Sun. Before the use of radar and sonic technology, scientists had to use math, specifically with something called the parallax. Now this just means estimating the distance of the Sun from different positions on Earth. To make this a bit simpler to understand, let's do a quick experiment. So first, hold up your finger and look at it. Now look at it with one eye closed. And now switch eyes. From this, you can see how the original position of your finger seems to change as the perspective from your eye switches. In the same way, from different positions on Earth, scientists could also guess the actual distance to the Sun, and this is how orbital lengths are figured out. Let's move on to the speeds of planets.
Earth moves around the Sun. Whoa! Pretty fast. Whoa! Kidding! Everybody already knows that. But have you ever wondered how humanity finally stopped thinking that everything revolved around them? Originally, in ancient Greece, people thought they lived in a geocentric world, where everything revolved around Earth in perfect circles, when in fact, everything orbits around the Sun.
In the 16th century, Nicholas Copernicus proposed a heliocentric universe where the Sun is at the center of the universe and the Earth moved around it. He also stated that the Moon revolved around the Earth. A century later, Johannes Kepler and Galileo Galilei supported Copernicus's theory with their own works. Despite this, the heliocentric model only caught on around 1758, and with a few adjustments, that's pretty much what we have today.
Now that we know that all planets are definitely orbiting around the Sun, we have to understand how to calculate their speeds, and for that, scientists needed distance and time. They already had their time period, 1 year or 365.25 days. They also knew the distance between the Earth and the Sun using parallax. Now imagine it as a radius of a big circle from a top view. To find Earth's orbit, scientists needed to find the circumference of that circle, and so they multiplied the radius by 2 pi. From that, they had estimated the distance of Earth's orbit around the Sun. Although this wasn't too accurate, as the orbit is not a perfect circle, scientists today have said the scientists from the Renaissance were very close to the real distance.